The ground is rising, not slowly, not imperceptibly. 1 meter in less than 20 years. Buildings crack open like eggshells, harbors lift themselves above the waterline. And beneath the city of Pozzuoli, beneath the cafes and the schools and the homes of 80,000 people, something is waking up. This is Campi Flegrei. You won't recognize it as a volcano because it doesn't look like one. There's no mountain, no cone of hardened lava piercing the sky. Just rolling hills, ancient ruins, thermal springs where Romans once bathed, and a caldera 13 kilometers wide that hides beneath it all. 39,000 years ago, this volcano ejected 200 cubic kilometers of ash into the atmosphere and plunged Europe into volcanic winter. It was 50 times larger than the eruption that buried Pompeii. 15,000 years ago, it did it again. And now, after 5 centuries of silence, it's moving. Thousands of earthquakes. Ground rising. Gases venting from cracks in the earth. Every measurement screams that something is changing beneath the surface. 3 million people live in its shadow. Most don't even know they're standing on a supervolcano. Scientists watch, they measure, they model. And they ask the question no one wants to answer, is this just another episode of unrest? Or is Campi Flegrei finally waking up? This is the story of the volcano that doesn't look like a volcano. The one that terrifies scientists more than Vesuvius. The one that could change everything. Let's explain how we got here. The volcano that doesn't look like a volcano. When we think of volcanoes, our minds conjure images of towering cones piercing the sky, their slopes draped in hardened lava, smoke curling from a crater at the summit. Mount Fuji, Vesuvius, Kilauea. These are the volcanoes of our collective imagination, dramatic and unmistakable. But what if I told you that one of Europe's most dangerous volcanoes looks nothing like this? What if I told you that you could walk across it, build a city upon it, and never once realize you were standing on a geological time bomb? Welcome to Campi Flegrei, the Phlegrean Fields, a sprawling volcanic system that defies everything we think we know about volcanoes. There is no mountain here, no obvious cone to warn us of the fury beneath. Instead, there are rolling hills, ancient ruins, bustling towns, and thermal springs where Romans once bathed. The city of Pozzuoli, home to over 80,000 people, sits directly within its boundaries. Naples, with its millions, lies just beyond the edge. And beneath it all, a vast chamber of molten rock waits, patient and restless. This is what scientists call a caldera, a word that comes from the Spanish for cauldron. It is formed not by the steady building of a volcanic cone, but by catastrophic collapse. When a volcano erupts with such violence that it empties the magma chamber beneath, the ground above simply falls inward, creating a vast depression. What remains is not a mountain, but a basin, often so large and so altered by time that it becomes unrecognizable as a volcano at all. Campi Flegrei is one such place. Its caldera stretches nearly 13 kilometers across, a hidden colossus beneath the surface of modern life. The lack of an obvious volcanic form is precisely what makes Campi Flegrei so unsettling. We are accustomed to dangers we can see, threats we can point to and avoid. But how do you avoid a volcano that looks like a landscape? How do you warn people that the ground beneath their homes, their schools, their churches is not solid earth but the roof of something far more volatile? The ancient Romans knew this place was special. They called it the entrance to the underworld, a realm where the god Vulcan forged his weapons in subterranean fires. They were not entirely wrong. The Phlegrean Fields have erupted dozens of times over the past 60,000 years. But 2 eruptions stand out in the geological record for their sheer magnitude. The first, the Campanian ignimbrite eruption 39,000 years ago, was one of the largest volcanic events Europe has ever witnessed. It ejected over 200 cubic kilometers of material into the atmosphere, plunging the continent into volcanic winter. The second, the Neapolitan yellow tuff eruption 15,000 years ago, was smaller but still colossal by any measure. Both of these eruptions formed the caldera we see today, collapsing the land and reshaping the coastline of the Bay of Naples. But Campi Flegrei is not a relic of the distant past. It is alive. And unlike the slumbering giants of our imagination, it does not sleep quietly. The ground here moves. It rises and falls in a phenomenon known as bradyseism, a slow-motion dance of inflation and deflation driven by the magma and gases below. Buildings crack. Harbors rise above the waterline. The earth itself seems uncertain, unable to decide whether it wants to rise or retreat. This is not the behavior of a dormant volcano. This is the behavior of a system under pressure, a system that scientists watch with growing concern. Before we continue this story, subscribe to the channel. Your support helps us tell the true stories of Earth's most powerful volcanoes. Imagine waking one morning to find that your street is no longer level. The pavement has buckled. Cracks snake up the walls of buildings that stood unblemished for decades. The harbor where fishermen once moored their boats now sits strangely high, its docks suspended above water that seems to have retreated. And then, months later, it all reverses. The ground sinks back down, the cracks widen, the sea reclaims what it had lost. This is not science fiction. This is daily life in Pozzuoli, the town at the heart of Campi Flegrei, where the earth itself refuses to stay still. The phenomenon is called bradyseism, from the Greek words for slow in movement. It is exactly what it sounds like. The gradual rising and falling of the ground, driven by forces deep beneath the surface. Unlike an earthquake, which strikes suddenly and violently, bradyseism unfolds over months or years, a relentless creep that transforms the landscape centimeter by centimeter. It is slow enough that you might not notice it day to day, but fast enough that within a human lifetime, the world can change beyond recognition. Pozzuoli knows this better than anywhere. The town sits directly above the most active portion of the Campi Flegrei caldera, and its relationship with bradyseism is ancient and intimate. In the Roman era, the magnificent temple of Serapis stood near the waterfront, a testament to engineering and devotion. Over the centuries, bradyseism caused the temple to sink below sea level, its marble columns becoming home to marine mollusks that bored holes into the stone. Then, in later centuries, the ground rose again, lifting the temple back above the waves. Those boreholes, frozen in the marble like a geological diary, tell the story of a coastline in constant flux. But it is the modern episodes of bradyseism that truly alarm scientists and residents alike. Between 1982 and 1984, the ground in Pozzuoli rose by nearly 2 meters. 2 meters in just 2 years. Buildings that had stood for generations became uninhabitable. Thousands of people were evacuated as cracks spread through homes and streets. The harbor transformed as the seabed rose, forcing boats into shallower and shallower waters. The town was in crisis, caught between the irresistible force of the earth beneath and the immovable need for people to live their lives. And then, as mysteriously as it began, the uplift slowed and eventually reversed. The ground settled. People returned to their homes, though many buildings bore the scars of the episode. But bradyseism in Campi Flegrei is never truly over. It is cyclical, a breathing rhythm of the earth. Since 2005, a new phase of uplift has been underway. The ground has risen more than a meter and it shows no signs of stopping. Each month brings new measurements, new data points on graphs that scientists study with obsessive attention. What causes this unsettling dance? The answer lies in the magma chamber far below, a vast reservoir of molten rock and superheated gases sitting several kilometers beneath the surface. When fresh magma rises into this chamber, or when gases accumulate and increase pressure, the chamber expands. This expansion pushes upward on the overlying rock, causing the ground to rise. When pressure is released, either through gas venting or magma retreating, the ground subsides. It is a system of pressure and release, inflation and deflation, playing out on a geological timescale that intersects uncomfortably with human timescales. The bradyseism of Campi Flegrei is accompanied by another phenomenon that keeps residents awake at night: earthquakes. These are not the massive, destructive quakes that flatten cities, but rather swarms of smaller tremors, most too subtle to feel but some strong enough to rattle windows and nerves. Since 2019, the frequency of these seismic events has increased dramatically. Thousands of small earthquakes have been recorded, clustering beneath Pozzuoli and the surrounding areas. Each one is a reminder that the caldera is not dormant. Each one is a data point that scientists feed into their models, trying to understand whether this is simply another cycle of bradyseism or something more ominous. The people of Pozzuoli live with this uncertainty every day. They have learned to read the signs. The new crack in a wall, the way a door no longer closes properly, the faint tremor felt while sitting at the dinner table. They attend town meetings where scientists present the latest monitoring data, trying to balance reassurance with honesty. Because the truth is that bradyseism, while unsettling, is not necessarily a precursor to eruption. Campi Flegrei has experienced numerous episodes of ground deformation over the centuries without erupting. But it has also erupted, most recently in 1538, and that eruption was preceded by significant ground uplift. Campi Flegrei and Mount Vesuvius. Are they connected? The question arrives with predictable regularity, especially when seismic activity increases or when the ground beneath Pozzuoli rises another few centimeters. Is Campi Flegrei connected to Mount Vesuvius? Could an eruption in one trigger catastrophe in the other? And what about those reports of an 8-kilometer crack linking the two systems? A subterranean fissure that could unleash both volcanoes simultaneously? The internet loves a good disaster scenario, and the proximity of these two volcanic giants, barely 25 kilometers apart, provides fertile ground for speculation and alarm. Let us begin with what we know. Campi Flegrei and Mount Vesuvius are indeed neighbors in geological terms, both sitting along the same tectonic boundary where the African plate subducts beneath the Eurasian plate. This subduction zone is the engine that drives volcanism throughout the region, forcing oceanic crust deep into the mantle where it melts and rises as magma. In this sense, they share a common origin story, born from the same fundamental geological processes that have shaped the Bay of Naples for millions of years. But sharing a tectonic setting is not the same as being connected. The critical question is whether the two systems have linked magma chambers, whether molten rock can flow from one to the other, creating a unified volcanic system beneath the surface. This is where science must separate fact from fiction, and where careful measurement must replace sensational headlines. Modern geophysical studies using seismic tomography and other advanced techniques have mapped the subsurface structure beneath the Bay of Naples in remarkable detail. What they reveal is that Campi Flegrei and Vesuvius each possess their own distinct magma chambers. These chambers sit at different depths and show different chemical signatures in the rocks they produce. Vesuvius tends to erupt magma that is somewhat different in composition from Campi Flegrei, a distinction that points to separate sources rather than a shared reservoir. Moreover, the pattern of earthquakes beneath each volcano follows distinct pathways. When Campi Flegrei experiences uplift and seismic swarms, the activity clusters beneath the caldera, particularly under Pozzuoli and the Solfatara crater. Vesuvius, meanwhile, generates its own seismic signals, independent of what is happening 25 kilometers away. If the two systems were hydraulically connected, if magma could flow freely between them, we would expect to see correlated activity, a synchronization in their behavior. We do not. So where does the myth of the 8-kilometer crack come from? Like many pieces of geological misinformation, it contains a kernel of truth wrapped in layers of misunderstanding. There are indeed fractures and fault systems in the region that run between the two volcanic areas. The Campanian plain is riddled with faults, the inevitable result of the tectonic stresses that created the volcanoes in the first place. Some of these faults are substantial and some do extend for many kilometers. But a fault is not a magma conduit. It is a break in the rock where movement has occurred. And while faults can sometimes provide pathways for magma to reach the surface, they do not automatically connect separate volcanic systems. The confusion is amplified when scientific papers discuss the structural relationship between Campi Flegrei and Vesuvius. Geologists rightly point out that the two volcanoes exist within the same regional stress field, and that changes in stress in one area could theoretically influence the other. This is a far cry from saying they are directly connected. It is the difference between two neighbors who share a street and two rooms that share a doorway. The volcanoes are related by geography and by their common tectonic parent, but they are not joined at the hip. There's also the matter of historical eruptions. If the two systems were truly connected, we might expect to see patterns in their eruptive history, moments when activity in one preceded or accompanied activity in the other. Yet, when we examine the geological record, no such pattern emerges. Vesuvius erupted catastrophically in AD 79, burying Pompeii and Herculaneum. Campi Flegrei was quiet. Campi Flegrei erupted in 1538, creating Monte Nuovo. Vesuvius showed no unusual activity. The two volcanoes marched to different drums. This is not to say that the proximity of Campi Flegrei and Vesuvius is irrelevant. The Bay of Naples is one of the most densely populated volcanic regions on Earth, and having two major volcanic systems in such close quarters presents unique challenges for hazard assessment and emergency planning. If both were to erupt within a short time frame, even independently, the consequences would be severe. But that is a question of statistical probability and risk management, not of physical connection. The responsible scientific position is clear. Campi Flegrei and Vesuvius are separate volcanic systems with their own magma sources and their own behaviors. They are not connected by an 8-kilometer crack or any other direct magmatic link. The fear that one will trigger the other is understandable given their proximity and the stakes involved, but it is not supported by the evidence. What we should fear is not their connection, but their individual capacities for destruction. Capacities that are formidable enough on their own. Everyone knows this mountain. Mount Vesuvius, the infamous volcano that buried Pompeii and Herculaneum in ash and fire. Its silhouette looms over the Bay of Naples, a constant reminder of nature's destructive power. For centuries, it has captured our imagination, a symbol of volcanic fury. But what if I told you the greatest volcanic threat to Europe isn't Vesuvius? What if the real danger is a hidden giant, a monster sleeping right next door, largely invisible and far more powerful? Today, we're journeying into the shadow of Vesuvius to uncover the terrifying secret of the Campi Flegrei, or the Phlegrean Fields. This isn't just another volcano story. This is about a threat on a scale that could reshape our world. To understand the danger, we first need to grasp a crucial geological difference. Vesuvius is what's known as a stratovolcano. Think of the classic volcano shape, a cone-shaped mountain built up by layers of lava and ash. It's impressive, yes, but its destructive potential is relatively localized. Campi Flegrei is something else entirely. It's a supervolcano. It doesn't have a single, obvious peak. Instead, it's a massive, sprawling caldera, a huge basin-like depression that formed after a colossal eruption emptied its magma chamber, causing the ground above to collapse. Imagine a volcano so big that it doesn't look like a volcano at all. The Campi Flegrei caldera stretches about 13 kilometers or 8 miles across. It's so vast that entire towns and cities like Pozzuoli and parts of Naples itself are built right inside it. Hundreds of thousands of people live their daily lives on top of a sleeping supervolcano, many without even realizing the scale of what lies beneath their feet. While Vesuvius is a mountain that could erupt, Campi Flegrei is the ground they walk on. The history of this place is written in layers of ash that stretch across continents. To find its most devastating chapter, we have to go back about 39,000 years. This was the time of the Campanian ignimbrite eruption, one of the most violent volcanic events in the last 200,000 years in Europe. It's hard to even comprehend the scale of this cataclysm. The eruption blasted an estimated 300 cubic kilometers of molten rock and ash into the atmosphere. That's enough material to cover the entire state of California in a layer of ash several inches thick. The eruption column would have soared into the stratosphere, blocking out the sun. The immediate area was incinerated by pyroclastic flows, superheated avalanches of gas and rock moving at hurricane speeds. But the effects didn't stop there. Ash from this single eruption has been found as far away as Russia. It triggered what's known as a volcanic winter. The vast cloud of sulfur and ash reflected sunlight back into space, causing global temperatures to plummet. For years, the world grew colder. This sudden climate shift had devastating impacts on ecosystems and early human populations, including the Neanderthals, who some scientists believe were pushed towards extinction by this very event. Compared to this, the eruption that destroyed Pompeii was a firecracker. So, if Campi Flegrei has this apocalyptic potential, why isn't everyone talking about it? Part of the answer lies in its deceptive nature. Unlike Vesuvius, it doesn't give clear mountainous warnings. Instead, its activity is subtle and dangerously unpredictable. The region is famous for a phenomenon called bradyseism. This is the gradual rising and falling of the ground as the magma chamber beneath fills or empties. Think of it as the supervolcano breathing. In the town of Pozzuoli, you can see the evidence firsthand. Ancient Roman marketplaces are now partially submerged, then re-exposed, as the ground level has shifted over centuries. In recent decades, this breathing has become more erratic. In the early 1980s, the ground rose by nearly 2 meters, causing significant damage and forcing the evacuation of thousands. Since 2005, the ground has been rising again, slowly but steadily. This activity is accompanied by thousands of small earthquakes, a constant swarm of tremors that keeps residents on edge and scientists on high alert. The problem is, no one knows what this means for sure. Is this slow uplift a prelude to a massive eruption, or is it just the volcano releasing pressure in a less catastrophic way? Forecasting an eruption here is incredibly difficult. Scientists can monitor gas emissions, seismic activity, and ground deformation, but there's no clear trigger that says the big one is coming, and that uncertainty is what makes the situation so terrifying. The sheer number of people living in the immediate danger zone is staggering. The red zone, the area at highest risk from pyroclastic flows, is home to over 500,000 people. The greater metropolitan area of Naples, with over 3 million people, sits right on the edge of the caldera. Evacuating this many people in a crisis would be a logistical nightmare of epic proportions. Imagine trying to move millions of panicked residents through congested city streets as the ground shakes and the sky darkens. The infrastructure simply isn't designed for a rapid mass exodus on that scale. This isn't a remote, unpopulated volcano in the middle of the ocean. This is a supervolcano simmering directly beneath one of Europe's most densely populated regions. The risk isn't just geological, it's profoundly human. Every day, life goes on under the Italian sun against a backdrop of stunning coastal beauty, but the threat from below is constant and growing. In the end, Vesuvius stands as the famous symbol, the postcard villain. But the true, silent giant of the Neapolitan landscape is Campi Flegrei. It is a geological marvel and a ticking time bomb all at once. Its beauty is deceptive, masking a power that has reshaped continents in the past and could wreak havoc on our modern world. This is why scientists from around the globe dedicate their lives to monitoring its every breath, every tremor, every puff of gas. They are the sentinels watching over a sleeping giant, hoping to provide a warning that could save millions. The people of Naples live with a unique blend of fatalism and joy, savoring life in the shadow of not one, but two immense volcanic threats. When you look at the beautiful Bay of Naples, remember what lies beneath. The story of Campi Flegrei is a humbling reminder that some of the greatest forces on our planet are the ones we cannot see. Thanks for watching. If you found this journey into the Earth's hidden dangers fascinating, be sure to like this video and subscribe for more deep dives into the wonders and warnings of our world. Stay curious. The year 1538 marked the end of a long silence. For nearly 3,000 years, Campi Flegrei had slumbered, its volcanic fury confined to fumaroles and hot springs, to the slow breathing of bradyseism that lifted and lowered the land. The Romans had built their empire atop it, bathed in its thermal waters, mined its volcanic rock for construction. Medieval towns had grown where Roman villas once stood. Generations lived and died without ever witnessing the caldera awaken. And then, in the autumn of 1538, everything changed. The warning signs began in 1534, 4 years before the eruption itself. The ground around Pozzuoli started to rise, gradually at first, then with increasing urgency. This was bradyseism, but on a scale that alarmed even those accustomed to the Earth's restlessness. The land lifted by several meters, transforming the coastline and draining parts of the sea. The beach at Pozzuoli became a raised platform. Springs that had flowed for centuries ran dry, their aquifers disrupted by the deformation below. Fish died in coastal waters, poisoned by gases seeping from the seafloor. Then came the earthquakes. Not the gentle tremors that occasionally rattled windows, but a relentless barrage of seismic shocks that grew stronger and more frequent as the months passed. Buildings cracked. People fled their homes, sleeping in the open air rather than risk being crushed by collapsing walls. The ground itself seemed to groan under some terrible strain, as if the earth were trying to tear itself apart. Contemporary accounts describe the terror that gripped the population, the sense that divine judgment was at hand. On the evening of the 29th of September 1538, the earth finally broke. A vent opened in the area of Tripergol, between Pozzuoli and Monte Barbaro, and the eruption began with explosive violence. Enormous columns of ash and gas shot into the sky, illuminated by the glow of incandescent rock fragments hurled from the depths. The noise was described as deafening, a continuous roar punctuated by explosions that could be heard across the Bay of Naples. Ash fell like black snow, covering the surrounding countryside in a blanket of volcanic debris. The eruption was phreatomagmatic in nature, meaning that rising magma encountered groundwater, and the resulting steam explosions amplified the violence of the event. This interaction between molten rock and water created the explosive energy that built what would become Monte Nuovo, the new mountain. Over the course of just a few days, possibly as little as 1 week, the eruption constructed a volcanic cone 123 meters high, an entirely new feature on the landscape where none had existed before. The human toll was mercifully limited by the standards of volcanic disasters. The area around the vent was not densely populated, and the days of warning earthquakes had driven most people away from the immediate danger zone. Historical records mention 24 deaths, though this number is uncertain and may be incomplete. What is clear is that the eruption could have been far worse had it occurred beneath the center of Pozzuoli or in a more populated area. Monte Nuovo stands today as a monument to that eruption, a grass-covered hill that seems almost pastoral in its quietness. Visitors can climb to its rim and peer into the crater, now colonized by vegetation, and struggle to imagine the violence that created it. But for volcanologists, Monte Nuovo is far more than a scenic landmark. It is a case study, a rare example of a historical eruption within a caldera system, documented by eyewitnesses and preserved in the geological record. What did we learn from 1538? First, that Campi Flegrei eruptions in the modern era may be preceded by significant ground deformation and seismic activity lasting months or even years. The 4-year period of uplift before the eruption is particularly significant, as it suggests that the system can show clear warning signs long before magma reaches the surface. This is both reassuring and troubling. Reassuring because it implies we might have time to prepare and evacuate. Troubling because it means that periods of unrest, like the one we are experiencing now, could potentially lead to eruption. Second, we learned that even relatively small eruptions in this caldera can be highly explosive when magma interacts with groundwater. The phreatomagmatic nature of the 1538 eruption is crucial to understanding future hazards. Campi Flegrei sits in a coastal area with a high water table. Any future eruption is likely to encounter water, and that interaction will determine the explosivity and ash production of the event. Third, and perhaps most importantly, Monte Nuovo taught us that Campi Flegrei remains an active volcanic system. The long silence between eruptions, whether 3,000 years or 500, does not indicate extinction. It indicates a volcano that operates on its own timeline, accumulating pressure over centuries before releasing it in brief, violent episodes. But Monte Nuovo also left us with troubling questions. Was it a standalone event, a release valve that bled off pressure and returned the system to dormancy? Or was it merely a small precursor to something larger? The eruption created a modest cone and ejected a relatively small volume of material, perhaps 0.02 cubic kilometers. This is nothing compared to the prehistoric super-eruptions that formed the caldera. If Monte Nuovo was the result of rising magma and 4 years of dramatic uplift, what would it take to trigger a larger event? Since 1538, Campi Flegrei has been quiet in eruptive terms, but it has never been dormant. The bradyseism continues, the ground rising and falling in its slow rhythm. The fumaroles at Solfatara vent steam and sulfurous gases. And now, in the 21st century, we find ourselves once again in a period of sustained uplift and increasing seismic activity. In the realm of volcanic monitoring, certainty is a luxury that scientists rarely possess. Volcanoes do not announce their intentions with clarity. They speak in ambiguous signals, in tremors and gases, in swelling ground and changing temperatures. The challenge for volcanologists is to read these signals correctly, to distinguish between the routine restlessness of an active system and the genuine precursors to eruption. At Campi Flegrei, where millions of lives hang in the balance, this challenge becomes existential. 3 primary indicators form the foundation of the monitoring effort. 3 signs that scientists watch with obsessive attention, knowing that the correct interpretation could mean the difference between catastrophe and successful evacuation. The first sign is seismic activity, the earthquakes that ripple through the ground as rock fractures and magma moves beneath the surface. Every volcano has a seismic signature, a baseline level of tremors that represents its normal state. At Campi Flegrei, this baseline is already unusually high. The caldera generates hundreds of small earthquakes each year, most too weak to be felt by residents but clearly recorded by the dense network of seismometers blanketing the area. What scientists look for is not the presence of earthquakes, but changes in their pattern, frequency, and location. Since 2019, Campi Flegrei has experienced a dramatic increase in seismic activity. Thousands of earthquakes have been recorded, with some strong enough to be felt across Pozzuoli and the surrounding towns. The strongest recent event in September 2023 registered magnitude 4.2, the most powerful earthquake in the area in 40 years. It cracked buildings, sent residents fleeing into the streets, and sparked urgent questions about whether an eruption was imminent. But an increase in earthquakes, alarming though it may be, does not automatically signal eruption. It signals movement, pressure, changes in the system. The critical question is what kind of movement? Scientists analyze earthquake swarms for specific characteristics. Are the tremors becoming shallower, suggesting magma rising toward the surface? Are they migrating laterally, indicating the opening of new pathways? Is there a shift from tectonic earthquakes caused by rock breaking under stress to volcanic tremor, a continuous vibration caused by fluid movement? These details matter enormously. The 1538 eruption was preceded by intense earthquake swarms that grew progressively stronger and shallower in the days before the vent opened. Current seismicity, whilst elevated, does not yet show that specific pattern of migration toward the surface. The second sign is ground deformation, the rising and falling of the earth that characterizes bradyseism. This is measured with extraordinary precision using GPS stations, satellite radar interferometry, and ground-based instruments that can detect changes of mere millimeters. At Campi Flegrei, the ground has risen more than a meter since 2005. And the rate of uplift has varied over time, accelerating and slowing in pulses that reflect changes in pressure below. Ground deformation tells scientists that the system is pressurizing. Something beneath the surface is expanding, pushing upward against the overlying rock. The question is what? In some cases, uplift is caused by fresh magma injected into the shallow chamber, bringing with it the heat and volatility that precede eruption. In other cases, it is caused by the accumulation and pressurization of hydrothermal fluids, superheated water and gases that can cause dramatic deformation without any magma movement at all. Distinguishing between these scenarios is crucial, and it requires combining deformation data with other monitoring techniques. Recent studies using advanced modeling suggest that the current uplift at Campi Flegrei may be driven primarily by hydrothermal processes rather than fresh magma intrusion. This would be relatively good news, as hydrothermal unrest can continue for decades without eruption. But the models are not conclusive, and the possibility of magma involvement cannot be ruled out. What is certain is that the rate of uplift correlates with earthquake frequency. When the ground rises faster, earthquakes increase. When uplift slows, seismicity decreases. This coupling suggests a unified source of pressure affecting both phenomena. The third sign is gas emission, specifically changes in the composition and volume of gases venting from fumaroles and the soil. Volcanic gases provide a direct chemical sample of what is happening at depth. As magma rises or degasses, it releases volatiles, primarily water vapor, carbon dioxide, and sulfur dioxide. By measuring these gases at the surface, scientists can infer changes in the magma system below. At Campi Flegrei, the Solfatara crater is the primary site of gas monitoring. This ancient crater, with its barren, sulfur-encrusted ground and hissing fumaroles, has been venting gases for thousands of years. But the composition of those gases changes over time. An increase in magmatic gases, particularly sulfur dioxide and certain isotopes of carbon and helium, would suggest fresh magma degassing at depth. Conversely, a dominance of hydrothermal gases would support the interpretation that current unrest is primarily fluid-driven. Have you ever heard of the Campi Flegrei? It's not your typical cone-shaped volcano. Imagine a giant sunken crater or caldera stretching 13 kilometers across just west of Naples, Italy. This isn't just a geological feature. It's a supervolcano, and it's stirring. Home to over 500,000 people, this region is one of the most densely populated volcanic areas in the world. And right now, it's experiencing a period of unrest that has scientists and residents on high alert. So what's actually happening? Since 2005, the ground in this area has been slowly but surely rising. This phenomenon is called bradyseism. Think of it like the ground is taking a slow, deep breath. In some places, the land is lifted by more than a meter. This uplift is accompanied by thousands of small earthquakes, most too faint to feel, but some strong enough to rattle buildings and nerves. Just this past May, a magnitude 4.4 quake, the strongest in 40 years, shook the region, causing minor damage and a lot of anxiety. This isn't the first time Campi Flegrei has acted up. It has a long and dramatic history. The caldera itself was formed by a colossal eruption about 40,000 years ago. an event so massive it influenced the climate across Europe. Another significant eruption occurred 15,000 years ago. More recently, in 1538, a smaller eruption created a whole new hill, Monte Nuovo, and in the early 1980s, a similar period of intense uplift and seismic activity forced the evacuation of 40,000 people from the nearby town of Pozzuoli. The ground rose by nearly 2 meters back then. So this current unrest is part of a long-running pattern. What's causing all this commotion? Scientists have two main theories. The first, and more worrying, is that magma is accumulating beneath the surface. As molten rock pushes upwards, it deforms the ground and fractures the rock, causing the uplift and the earthquakes. The second theory is that the activity is driven by hydrothermal fluids. This means superheated water and gases trapped underground are expanding and pushing up the ground. It's possible, and even likely, that both processes are happening at the same time. The key question for scientists is which one is the dominant force. To figure this out, they're using a whole arsenal of monitoring tools. GPS stations track the ground movement down to the millimeter. Seismometers record every little tremor. Gas sensors sniff the air for volcanic gases like carbon dioxide and sulfur dioxide, which can signal magma rising closer to the surface. By analyzing all this data, scientists at Italy's National Institute of Geophysics and Volcanology are trying to understand if the volcano is getting closer to an eruption. Recent studies suggest the crust is becoming weaker and more prone to fracturing, which could make it easier for magma to break through. This brings us to the big question. What could an eruption look like? We're not talking about a single outcome here. The most likely scenario, and thankfully the least destructive, would be a small phreatic or steam-driven explosion. This happens when underground water is rapidly heated by magma, flashing into steam and causing a localized blast. It would be dangerous for anyone nearby, but its impact would be limited. A step up from that would be an eruption similar to the one in 1538 that formed Monte Nuovo. This would involve lava fountains, ash columns, and the creation of a new volcanic cone. While more significant, it would still be a relatively localized event, primarily affecting the immediate area within the caldera. The evacuation plans currently in place are designed for this type of scenario. The red zone, the area at highest risk, would need to be evacuated, which involves about 500,000 people. A larger yellow zone, home to over 800,000 people, would be at risk from falling ash. This would be a massive logistical challenge, but it's a scenario that authorities are actively preparing for. Then there's the worst-case scenario, a super eruption, like the one that formed the caldera tens of thousands of years ago. This would be a cataclysmic event, ejecting hundreds of cubic kilometers of ash and rock into the atmosphere. The ash cloud would block out the sun, causing a volcanic winter and dramatically cooling the global climate. This would lead to widespread crop failures and have devastating consequences for civilization as we know it. Let's be very clear, though. Scientists agree that the probability of such an event happening anytime soon is extremely low. The current signs just don't point towards that kind of colossal energy buildup. So, while a civilization-ending super eruption is the stuff of disaster movies, the more realistic threats of smaller eruptions are very real for the people living on top of this restless giant. For them, the constant trembling of the ground is a reminder of the power simmering just a few kilometers beneath their feet. The Italian authorities are not taking any chances. They have detailed evacuation plans, conduct regular drills, and are constantly updating their emergency procedures based on the latest scientific data. The goal is to be prepared for the most likely scenarios, ensuring they can move hundreds of thousands of people to safety if needed. Living with a supervolcano is a unique and challenging reality. It's a delicate balance between respecting the immense power of nature and carrying on with daily life. The story of Campi Flegrei is a powerful reminder that the ground beneath us is not as solid as it seems, and that some of the planet's most beautiful landscapes are also its most volatile. As science continues to unravel the secrets of this sleeping giant, the world watches, hoping it stays sleeping for a long, long time. Thanks for watching. If you found this fascinating, don't forget to like this video and subscribe for more deep dives into the powerful forces that shape our world. See you next time. What scientists emphasize is that the figure of 3.5 million people at risk, a number that appears frequently in media reports, is a theoretical maximum based on the worst-case scenario. It assumes a large eruption with pyroclastic currents extending to their maximum possible range. It includes everyone who might potentially be affected under the most extreme conditions. This is useful for planning purposes, for ensuring that authorities have considered the full range of possibilities. But it is not a prediction of what will actually happen. The Vesuvius Observatory sits on a hillside overlooking the Bay of Naples, a neoclassical building that has watched over the region's volcanoes since 1841. It is one of the oldest volcano observatories in the world, founded in an era when volcanic monitoring consisted of little more than visual observations and barometers. Today, it is the nerve center of a sophisticated surveillance network that transforms Campi Flegrei into perhaps the most intensively monitored volcano on Earth. Every tremor, every millimeter of ground movement, every shift in gas composition is recorded, analyzed, and fed into models that attempt to divine the caldera's intentions. The monitoring network is staggering in its scope and precision. More than 30 seismic stations surround the caldera, detecting earthquakes so small that no human could feel them. GPS stations measure ground deformation continuously, tracking the rise and fall of the Earth with millimeter accuracy. Satellite radar interferometry provides a broader view, creating detailed maps of how the entire caldera is deforming over time. Geochemical sensors sample gases from fumaroles and soil, looking for changes in composition that might signal magma movement. Gravity meters detect subtle changes in the mass distribution underground. Temperature probes monitor thermal variations. Even the magnetic field is measured, as rising magma can alter local magnetic properties. All of this data flows into computer systems where algorithms search for patterns, for deviations from baseline, for the subtle signatures that might distinguish routine unrest from genuine precursors to eruption. Machine learning models trained on decades of monitoring data attempt to recognize the fingerprints of different volcanic processes. Scientists analyze the data in real time, comparing current observations to historical records, to the behavior of other calderas worldwide, to theoretical models of how volcanic systems evolve toward eruption. Yet for all this technological sophistication, for all the data streaming in every second of every day, uncertainty remains. The fundamental challenge is that calderas like Campi Flegrei do not have simple, linear pathways to eruption. They are complex systems with multiple feedback loops, where pressurization can lead to fracturing that releases pressure, where gas escape can reduce the explosivity of magma without reducing the volume, where hydrothermal circulation can mask or mimic magmatic signals. The system can show all the warning signs and then simply settle back down, pressure vented, crisis averted, leaving scientists to wonder whether they dodged a bullet or were worried over nothing. This ambiguity creates profound challenges for civil authorities. The Italian government operates a 4-level alert system for Campi Flegrei, ranging from green baseline activity through yellow attention, orange pre-alarm, and red alarm. Each level triggers specific actions, from increased monitoring to evacuation. But deciding when to raise the alert level is an agonizing decision that must balance scientific uncertainty against public safety and economic disruption. Raise the alert too early, evacuate without an eruption, and you face public backlash, economic catastrophe, and the very real risk that people will ignore future warnings. The boy who cried wolf is not just a fable. It is a genuine concern in volcanic crisis management. Keep the alert level too low, wait too long for absolute certainty, and you risk having thousands trapped when the eruption begins. The experience of other volcanic crises shows how difficult this balance is. At Mount Pinatubo, scientists got it right, evacuating just in time. At Nevado del Ruiz in Colombia in 1985, warnings were ignored or downplayed, and 23,000 people died in mudflows. The people of Pozzuoli and the surrounding communities live with this uncertainty every day. They feel the earthquakes, watch the cracks appear in their buildings, attend the public meetings where scientists explain the latest monitoring results in language carefully calibrated to inform without inducing panic. Many have lived through previous crises, particularly the dramatic uplift of the 1980s, when thousands were evacuated and the town teetered on the edge of catastrophe before the crisis passed. That experience cuts both ways. For some, it provides reassurance that unrest does not necessarily mean eruption. For others, it fosters a dangerous complacency, a sense that the volcano is crying wolf again. There are divisions within the community about how to respond. Some call for more aggressive action, for preemptive evacuation or restriction of development within the caldera. Others resist, arguing that life cannot be perpetually suspended in anticipation of a disaster that may never come. Property values within the yellow zone have fallen, but people continue to live there, to raise families, to run businesses. What choice do they have? This is their home, and homes cannot simply be abandoned because of statistical risk, no matter how carefully calculated. The Italian government has invested heavily in preparedness, developing evacuation routes, designating assembly points, conducting drills to test the logistics of moving hundreds of thousands of people to safety. The plan calls for evacuees to be relocated to other regions of Italy, with each municipality within the danger zone twinned with a host municipality elsewhere in the country. In theory, the entire yellow zone could be evacuated within 72 hours of a red alert being declared. In practice, no one knows whether such a massive, rapid evacuation would actually work when tested by a real crisis rather than a drill. There is also the question of rebuilding and return. After the 1980s crisis, people returned to Pozzuoli when the immediate danger passed, but many buildings remained damaged and the town bore the scars of evacuation for years. If a future eruption actually occurs, even a small one, would anyone return to live within the caldera? Or would this mark the end of 3,000 years of continuous habitation, a forced abandonment of one of the most historically rich landscapes in Europe? Scientists continue their vigil, publishing papers, refining models, debating interpretations. The current phase of unrest shows no signs of ending. The ground continues to rise, though the rate has fluctuated. Earthquakes continue to rattle the region, some strong enough to damage buildings and frighten residents. Gas emissions remain elevated. Every measurement is scrutinized for what it might reveal about the caldera's intentions, for whether this time is different, whether this episode of unrest will finally culminate in eruption, or whether Campi Flegrei will once again subside into restless sleep. There is a peculiar cruelty in the timescales of geology. Volcanoes operate on rhythms measured in centuries and millennia, whilst human lives flicker past in mere decades. We build our civilizations on volcanic soil, drawn by its fertility, by the harbors and hot springs and dramatic beauty of volcanic landscapes. We live and love and die, generation after generation, and the volcano sleeps. And then, on a timescale that means nothing to the mountain but everything to those living upon it, the volcano awakens, indifferent to the cities we have built, the lives we have woven into its slopes. Campi Flegrei has been home to humans for thousands of years. The Greeks established colonies here, drawn by the natural harbors and the mysterious landscape they called the Phlegrean Fields, the Burning Fields. The Romans built an empire that touched 3 continents, and they made this caldera one of their jewels, constructing temples and bathhouses, villas and amphitheaters. They knew the ground moved. They knew steam rose from cracks in the earth. They called it the entrance to the underworld, and perhaps in that mythology they encoded a deeper understanding of what lay beneath. Medieval towns rose where Roman cities fell. The Renaissance brought new architecture, new art, new ways of understanding the world. The modern era brought industry, dense urbanization, the technological capacity to monitor the earth with unprecedented precision. And through it all, Campi Flegrei continued its slow breathing, rising and falling, occasionally rumbling, always present but rarely violent. The last eruption was nearly 5 centuries ago, in 1538. For context, that was before Shakespeare wrote his plays, before Galileo looked through a telescope, before the scientific revolution that would eventually give us the tools to understand what volcanoes actually are. 500 years is a long time in human terms. It is long enough for collective memory to fade, for an eruption to become history rather than living experience. No one alive today has seen Campi Flegrei erupt. No one's grandparents saw it erupt. The event has passed from memory into record, from visceral experience into academic study. And yet 500 years is nothing to a volcano. It is a brief pause between breaths, a moment of rest in a cycle that stretches back hundreds of thousands of years. This disconnect between geological time and human time creates a fundamental problem for risk assessment and public perception. We struggle to take seriously dangers that operate on timescales beyond our experience. A volcano that last erupted in 1538 feels intuitively like a historical curiosity rather than an active threat. The rational mind understands that 500 years of dormancy does not mean the volcano is extinct. The emotional mind, the part of us that assesses risk based on immediate experience, struggles to treat something as dangerous when it has been quiet for longer than nations have existed. And yet the monitoring data tells us that Campi Flegrei is not dormant. It is active, restless, showing signs of pressurization and unrest that demand attention. The ground has risen more than a meter since 2005. Thousands of earthquakes have shaken Pozzuoli and the surrounding areas. The system is changing, evolving, doing something beneath the surface that we cannot directly observe, but can only infer from the signals it sends to the surface. Whether this unrest will lead to eruption remains unknown. The caldera has experienced similar episodes in the past without erupting. The uplift of the 1980s was dramatic, alarming, and ultimately inconclusive. The system pressurized, frightened hundreds of thousands of people, and then relaxed without producing magma at the surface. Perhaps the current unrest will follow the same pattern. Perhaps decades from now, scientists will look back on this period as another episode of bradyseism, another false alarm in the long history of living above a restless caldera. Or perhaps this time is different. Perhaps the magma that has been accumulating at depth for centuries is finally approaching the threshold where it must find release. Perhaps the warning signs we see today are the opening notes of a symphony that will culminate in eruption, adding a new chapter to the geological history of Campi Flegrei. We cannot know. We can only watch, measure, model, and prepare. What we can say with certainty is that Campi Flegrei will erupt again. It is not a question of if, but when. The caldera is not extinct. It is merely resting, and on geological timescales, that rest will inevitably end. Whether the next eruption comes next year or in 1,000 years, whether it is a small event like Monte Nuovo or something vastly larger, it will happen. The volcanic system that created the Bay of Naples, that buried Neanderthals under meters of ash 39,000 years ago, that built mountains in a week in 1538, has not finished its work. This certainty sits uncomfortably alongside the uncertainty of when and how. It creates a permanent state of potential crisis, a sword of Damocles hanging over one of the most densely populated regions in Europe. 3 million people live in the shadow of this volcano, most of them unaware of or unconcerned by the danger. They have lives to live, work to do, families to raise. They cannot live in perpetual fear of a disaster that may not come in their lifetime. Yet the responsibility of scientists and civil authorities is to ensure that when the volcano does awaken, when the unrest transitions from chronic to acute, from ambiguous to undeniable, the people living above, the fire have the knowledge and the means to escape. The monitoring networks, the emergency plans, the evacuation routes, all of this infrastructure exists to bridge the gap between geological time and human time, to give us the warning we need to step aside when the mountain decides to move. Campi Flegrei teaches us humility. It reminds us that we live as guests on a dynamic planet, that the ground beneath our feet is not as solid as we imagine, that forces beyond our control shape the world we inhabit. It challenges us to think across timescales that dwarf human experience, to take seriously dangers that may not manifest in our lifetimes but are nonetheless real. And it asks us whether we have the wisdom to listen to the earth when it speaks, to heed the warnings encoded in tremors and rising ground before those warnings become catastrophe.